So what is Kubernetes? Well, you know that company Google? Kubernetes is 15 years of Google's experience running containers in production. That's 15 years of not just Google's experience, but an entire community of experts who are passionate about this very subject. So before Kubernetes, we used to get things from other humans. We had your sysadmin over here, and on this side, you had your person who just wanted to get their service up and running. That person would order things like VMs, load balancers, reverse proxies, etc. And they would log these as tickets to the sysadmin. This process was slow and error prone, and it made the sysadmin over here very sad indeed, because this was a lot of work. So how do we fix this problem? So Kubernetes takes away all these things that we've created here, all of these VMs, load balancers, ingresses, reverse proxies, and we take this stuff and we put it in our cluster here. We take a few nodes and put them together, and when we create this Kubernetes cluster, we abstract everything away by providing all of these things like VMs, load balancers, ingresses, etc. through the Kubernetes API. And all of these are now generic services. So what is Kubernetes then? Kubernetes is a container orchestrator. Kubernetes is good at running containers on multiple nodes and making those containers highly available. So you don't have to mess around with Docker and spinning up a container on another and another and another and another node, or worrying about when things crash. Kubernetes does all of this magic for you, and it can move all your containers around these nodes with ease. Kubernetes is declarative. So you have everything specified in a little file here, like an order from the menu, and you tell Kubernetes what your service looks like, and it keeps a record of that inside of its API. You send that request off to Kubernetes and it starts cooking it up for you. You just tell Kubernetes you want something generic, and the admin configures what specific technology delivers that capability. You don't have to care about how the magic happens, it just does. For instance, let's think about a resource like storage. Realistically, that could be S3, that could be elastic block storage, that could be something like MinIO. The point is though, you wouldn't have to know or care. From now on, you declare that as your persistent volume that you need, and you send that off to Kubernetes. You don't have to care how it's done. So we have this whole cluster of machines here, and Kubernetes takes away the idea of thinking about all of these as actual VMs or nodes, and thinks about them as just the compute that they provide, which is CPU and memory. Each one of these is a representation of CPU and memory that's available for people to consume, as well as a bit of storage, which could also be outside of the cluster. Remember, we don't have to care. We just need CPU and memory and other things to run our service. So the cluster will generally have two types of nodes. You'd have your control plane nodes here at the top, and you'd have some worker nodes here at the bottom. And these control plane nodes would move containers around the cluster, and they're very good at keeping track of what's in your manifests and translating that to something that's actually here in the cluster. And these worker nodes generally host workloads. Pretty straightforward. So how do you use all of this goodness? Well, this doesn't speak to everything, but you generally have some high-level resources that you would use to interact with Kubernetes. Now remember, we want to run containers in here. So how do you get a container into Kubernetes? Well, the lowest level resource that you can get, or I'd rather say the smallest unit that you can get, is called a pod. And like a pod of orcas or peas in a pod, it can have many or one container. So if we think of our pod down here, and all of the containers in it, you realize that it's a container of containers. And you have 1, 2, 3, or one container in here. And this pod will get scheduled, which just means that these control plane nodes are going to go and put it on one of these worker nodes that has CPU and memory available to host this thing. It's going to place it on one of these worker nodes. And that pod is now here on this node here. This pod by itself, though, is not very useful. If this goes down, so does your service. So how do we make sure that we have more than one of this pod? That's where something like a deployment comes in. Now, a deployment says I have 1, 2, 3, 4 replicas of this pod. And what that would look like translated is that you might have one over here, 2 over here, and none over here. But it'll distribute it as evenly as it can amongst these nodes. So this is a way of scaling your pods, saying I want at least 4. You can change this to 5, and we can schedule another one on this node here, or one of the other nodes. You can also do this automatically with something called a horizontal pod autoscaler, which we'll cover in the future when I cover scaling. But for now, just know that a deployment says that we have 4 replicas of this pod, which, as we said before, is now a container running in the smallest unit it can in Kubernetes. And this makes our resource highly available. If this goes down, we still have this or these over here. And once that goes down, Kubernetes is going to automatically spin up another pod over here on a node that is still alive and working. This is what makes Kubernetes a self-healing system. That solves the problem of high availability here. But how do we communicate with these nodes? Communication between all of these pods here in the deployments is done through a service. So now, to explain how a service distributes traffic between these workloads here, I'll also explain how the deployment actually takes ownership of these pods as well. This pod has a little label on it, a label called app1. And this deployment has a label selector. It says I am looking to take ownership of everything that is app1. So every time it finds an app labeled app1, it's going to take ownership of it. It's going to become part of this deployment, or also sometimes known as a replica set. The service does the same thing. It's saying I'm looking to distribute traffic between services labeled app1. And when it finds them, it's going to distribute that traffic evenly between the workloads. Every time something hits the service, it's going to hand it over to this pod, this pod, this pod, this pod, and all of them will get a chance to service the traffic. From a development perspective, you can also use something called a node port, and you can actually hit these nodes directly. It would be facilitated by the service, but technically now a developer can hit their service running here and test that it's actually working. And these services inside of the cluster, if there was a deployment outside of yours, could also talk to your service and communicate with your pods. Now, when you're outside of Kubernetes, generally in the world of the internet, we use a host name. So how would you communicate with the service? That's where an ingress comes in. An ingress has a whole bunch of rules. And those rules say that once I get a domain in here and a path, when I find something that matches this domain over here and the path here, maybe the path is app or whatever it may be, I'm going to take that, I'm going to give this traffic to this service over here. So if we're looking at the high level flow of things, generally things would flow in from the ingress, hit the service, hit the deployment, which is just all of these pods here, and now your pods would service all of this traffic. And there you have it. Those are all the basic resources that you need to deploy something inside of Kubernetes. Of course, there's a lot more, but these are just the basics. And we'll go over deploying an actual deployment like this in a test application that I've created to demonstrate how this stuff actually works. But it's good for you to know the high level flow. And just to cover that again, we go here from the ingress. So it goes from the ingress to the service to the deployment. Here our ingress has all the rules. Our service can distribute traffic between all of our pods. And our deployment makes sure that our pods are highly available. Ingress, service, deployments, and pods. That's a high level flow of how it works. So to cover what we've just gone over now, Kubernetes is a container orchestrator that takes complex things that people have dealt with in the past when running containers in production and abstracts them away and commoditizes them. This makes it easy to run containers in production without having to think about all of the magic that you have to get right to make sure these things self-heal, that they're highly available, that the traffic is evenly distributed, and that services can communicate with each other. This is the real value of Kubernetes and what it is. So if you found value out of that, you know which buttons to press. And until next time, friends, when we cover doing an actual deployment, you'll find my next video over here.